This is a demonstration of our project. It is run through Flask on Python, so the first step is to run it. As you can see, when we run Flask, the first thing it does is start up a web server endpoint. We're currently running on localhost, so it's 127.0.0.1 port 5000. This IP can be changed in the settings. If we go to that URL, we'll see that Flask shows us all of the endpoints that can be runnable on this program. We have /loadrobot, /addGoTo, and /calculate, and these are all REST endpoints. Furthermore, the parameters are all explained so that we understand for each of these endpoints what our Flask program requires. However, for a more user-friendly interaction, what we can do is go to the same URL, /calculate page. This page allows us to do the same exact thing, but through interactive boxes. So for example, we can see in parameters we have capacity, speed, acceleration, payload, etc. So I'm going to give a live demonstration of this. I'm going to enter in a few test values. For example, for the capacity, I'm going to enter in 35, speed 1000, acceleration 300, payload 30, wait time 4, and model of the robot is LD90. If we click submit, a robot's UUID is generated. If I go ahead and add more data and fill out the entire form for the first row, the point capacity being a place where the robot will go to and how fast the robot reaches that area, we can see that a graph will be generated. This graph will help us and the Omron team be able to better estimate the robot's battery capacity. Now if we go back and we go to the REST APIs, we can actually use a program called Postman, or any web browser for that matter, in order to go ahead and load the same data in. I'm going to give an example of the same thing, where we have the capacity, speed, acceleration, payload, wait time, and model. I'm going to go ahead and send that over to our Flask endpoint, and we can see that a robot UUID is generated. This robot UUID is the identifier that's required in order for us to track this robot. Next, we can add a few points to the robot. So for example, if we add a point where its capacity is 8 and its speed is 2, we can send it, and that point will be successfully added. We can further add a few more points to the graph to further populate and add and accurately reflect how the robot will react on each of these endpoints. So I've just added 3 additional endpoints. Once we are satisfied that all the endpoints have been added, we can go ahead and instruct the server to calculate the graph. Over here, all we have to do is enter the same identifier of the robot and click send. After it's complete, what will happen is Flask will generate a graph that is also going to create an image on the desktop of that user, right here. For live metrics and easier access of data, which is more aggregated, what we can do is go to our Flask endpoint right here and do /metrics. The metrics over here displayed are actually parsable by Prometheus and Grafana, and as long as these two programs are ran on an open live web server, then they will be displayed as gauges. Over here though, it is just displayed as plain text, so we can see, for example, that the total current cycle of one of our robot UIDs is 33.82. We can see that the total robots created are shown, as well as all the other uptimes and whatnot. So using this program is quite simple and can easily allow us to calculate multiple robot battery calculations at once.